A very good morning to the examiners. My name is Liew Yoong Ler, and today I'm going to present my study with the title of Finite Element Analysis of Cutting Temperature in Turning Process using Box-Bangor Response Surface Method. This study is focused on the simulation of the turning process by using the FEA deformed 3D software. Furthermore, the interaction between the cutting parameters and the output response are investigated by using the RSM method. Then the ANOVA analysis method is employed to determine the most influential cutting parameters on the output response. Nowadays, achieving a high-quality turn product is the challenge that faced by the manufacturing industry. So the standard approach in obtaining the optimal cutting parameters is strongly required by the manufacturing industry. And this study consists of three objectives. The first objective is to determine the most influential cutting parameters on the output response. The second objective is to investigate the interaction between the cutting parameters and the output response. And the third objective is to optimize the cutting parameter setting of the turning process by using the Box-Bangor response surface method. The Box-Bangor response surface method was used as a statistical tool for the design of simulation runs. Based on the Box-Bangor design matrix, there are 13 simulation runs with one standard point. And this table shows the value ranges of the cutting parameters for this study. Next, the FEA deformed 3D simulation setup began by selecting the turning process as the machining type. Then set out the process parameter and the process condition. Then the uncoded carbide triangle turning insert TMMF432 was selected from the deformed 3Ds library, and the tool mesh generation is set by default of 25,000 and with a size ratio of 4. Then the workpiece was set as the simplified model with a length of 10 mm, and the workpiece meshing is generating by selecting the absolute mesh size with a defined size of 25% of fit. Then the aluminum alloy 7075 was selected and the number of simulation step was set to 500 steps. Then it can proceed to the database generation and then start the turning simulation. In the result and discussion part, this table shows the simulation result for the cutting temperature for all the 13 simulation runs. And the table shows that the run 5 has the lowest cutting temperature of 447 degrees Celsius. And this figure shows the appearance with the cutting tool for the minimum cutting temperature in the run 5. From the ANOVA analysis for the cutting temperature shows that the most influential cutting parameters on the cutting temperature is the depth of cut, due to its lowest p-value of 0.133, and it is supported by the Alban and Hamidullah stated that the cutting temperature is increasing when there is an increase in the depth of cut due to the increase in the chip section and the friction of the two chips. Furthermore, the Pareto chart of the standardized effect justified that the interaction between the cutting speed and the depth of cut, which has a p-value of 0.072, is the predominant interaction that gives the most effect on the cutting temperature. Since the model term of AC, which represents the interaction between the cutting speed and the depth of cut, is close to the standardized effect of 2.365. Next, this figure shows the surface plot of the cutting temperature versus the depth of cut and the cutting speed. As you can see from the surface plot, the cutting temperature is increasing when there is an increase in the depth of cut and a decrease in the cutting speed. And this finding is supported by main claim that the cutting temperature began to decrease when the cutting speed is surpassed the peak certain critical value due to the time for the heat transfer into the workpiece is reduced and most of the heat is evacuated by the chips. Next, this table shows the optimization parameters of the cutting temperature, which are the cutting speed is 200 meters per minute, the feed rate is 0.25 mm per revolution, and the depth of cut is 0.5 mm. They give the minimum cutting temperature of 401.89 degrees Celsius. And the percentage optimization of 11.22% indicates that the cutting temperature has optimized by 11.22%. In conclusion, the three objectives of this study have achieved. First, the most influential cutting parameters is the cutting temperature, which is the depth of cut. Second, the cutting temperature is increasing when there is an increase in the depth of cut and a decrease in the cutting speed. Third, is the optimization parameters of the cutting temperature, which are the cutting speed is 200 meters per minute, the depth of cut is 0.5 mm and the feed rate is 0.25 mm per revolution, which gives the minimum cutting temperature of 401.89 degrees Celsius. That's all for my presentation. Thank you.